All right, so here we have the three-dimensional representation of the production function. There's an enormous amount of detail on this kind of three-dimensional graph. We're taking all possible combinations of labour and capital, and we're seeing what the corresponding levels of output will be. Now, whilst we have a lot of information in this graph, it's actually very cumbersome to work with these three-dimensional surfaces. And so we often make a simplification to the way we visually represent the production process or the production function, a way that enables us to very quickly start learning about some profound key structural forces that underlie the entire process of economic growth. And we achieve this by doing the following. I'm going to work for the time being under the following set of circumstances, where I'm going to hold the amount of labour and also the amount of total factor productivity fixed, unchanging. Now we'll change that shortly, but for the moment let's just assume that we're looking at a production process where there's a fixed amount of labour and where total factor productivity is not changing. And that all we do is map or graph what happens to output when we vary capital. When we do that, we no longer have to work in this three-dimension space. We can work in 2 dimensions only and use what is called the two-dimensional production function. So remember, we're holding labour and total factor productivity fixed, and we're looking at what happens to output when we vary capital. And there are 2 key characteristics of this experiment that this graphical approach, this two-dimensional production function, really nicely captures. First, and I guess most obviously, what we are able to represent here is the idea that as you provide more capital to the production process, the implication of that is more output can then be derived. Second, however, is this concept of the diminishing marginal productivity of capital. That as the amount of capital increases, the marginal product of capital, the extra output that we get, falls. So we still are getting extra output, but you're getting smaller increases of output the more capital you have. And that is illustrated very nicely by the following. So here we have increased the amount of capital, and then we can read off the vertical axis how much extra output is the result. If we repeat that experiment but down the right-hand side of the horizontal axis, where we start already with a high level of capital and add a bit more capital, well, you can see that the increase in output we get is much smaller. So it is the curved shape of the production function that is reflecting the diminishing marginal productivity of capital. There are other things we can illustrate on this diagram that are going to be very useful for us. Let's think about the following experiment. And the experiment is this. This time I want to show you how the two-dimensional production function can be used to illustrate the following circumstance, where we hold labour and capital fixed. This time I'm going to increase total factor productivity. We saw with our three-dimensional production function that what an increase in total factor productivity did was to shift the surface of that production function upwards. In two dimensions, it's actually a similar sort of concept. So we're going to hold capital fixed at some level, and behind the scenes we're not changing labour either. If we increase total factor productivity, holding capital and labour unchanged, well, that increase in total factor productivity itself should be sufficient to generate us some extra output. Think of it as an improvement in technology, for example, or work practices, or the skill of labour. Any of those sorts of factors, should they increase, are likely to result in more output. So we can illustrate that by an upward shift of this production function. We haven't changed capital, as you can see, nor have we changed labour, but the increase in total factor productivity is sufficient to generate more output. So even though it's a very simple representation, 2 dimensions, not even 3 dimensions, there's still a lot of detail here. We've been able to capture the fact that more capital means more output. We've been able to capture the fact that there is a diminishing marginal productivity associated with capital. And we've also been able to capture the fact that should total factor productivity improve, then we can also represent what that implies for output. So it's a very, very simple analytical tool that conveys an enormous amount of information we're going to exploit as we delve behind the scenes of economic growth. There's one more refinement to the analysis I'm going to make, and that is to work with what is called the per capita production function. You'll remember that when we think about economic growth, what we're ultimately trying to explain is what is happening to per capita aggregate income in the economy, the average amount of income per person. So I want to work with a notion of production function that is also in per capita terms, that relates to the production process from the viewpoint of, if you like, an average worker in the economy. And I'm going to do that by making a very simple assumption, which is going to enable us to work in per capita terms very conveniently. And this is to assume that everybody in the population works. Now, I don't have to assume that for this analysis that we're going to go through, but it absolutely makes things much, much simpler to show without actually adding any complications that we would necessarily have to be concerned about. So if we assume the entire population works and then measure on the vertical axis not just output as we did previously, but this time output per worker. So in that expression I have L. Now, L now is the notation I'll use for my labour force. So what I have on that left-hand side is per capita output, or per worker output, I should probably say. But given that everybody in the population works, what I have in fact there, remembering that output and income are exactly the same things, is I have a measure of per capita income. And that's what the analysis of economic growth is designed to explain or understand. What are the key factors or forces at work that determine per capita income? On the horizontal axis, I have the amount of capital relative to the number of workers. That is known as the capital labour ratio. Think of this as the average amount of capital that is available to a worker when they turn up for work. So here we have the production function per capita terms. We have per capita output, which is the same as per capita income on the vertical axis, and the capital labour ratio, the amount of capital available in the economy per person on the horizontal axis. Note that by working with this per capita production function, we are very much focusing the analysis on average productivity. You'll recall from earlier that we can decompose real GDP into two sets of factors, one relating to average productivity, the second relating to the proportion of the population who work. But if we make this assumption that everybody works, then the only factor that really matters is therefore average productivity. And indeed, that's what we're measuring on this vertical axis, the amount of output per person who works. And so by working with this per capita production function, the focus of the analysis very much becomes a story about average productivity. And that's probably the best way to think about how we're going to proceed. So it's going to have similar characteristics to what we had previously, so that now if we increase not capital on its own, but the amount of capital per person, if we increase the capital labour ratio, that by itself will be sufficient to generate higher average productivity or to generate higher per capita income. So that increasing the capital labour ratio, providing each worker with more capital, in other words, is a path to economic growth. It increases the flow of per capita income. But there's an alternate path to growth, and the alternate path to growth is through growth in total factor productivity. And as before, that can be represented by an upward shift, this time in the per capita production function. This simple concept of the two-dimensional per capita production function will already enable us to say some important things about the process of economic growth. I'm going to explore two implications, and these implications will turn out to be very important to economists' story about what ultimately really matters for economic growth. So implication number one relates to that idea of the diminishing, which I'll just abbreviate to DIM, the diminishing marginal productivity of capital. Strictly speaking, in this case, the diminishing marginal productivity of providing more capital per person. Suppose we did exactly that, starting with a relatively low amount of capital per person. You could think of this as an economy starting its process of economic growth from a relatively low base. It started not having that much capital per person, and we provide that economy with some extra capital. What you can see is that that yields quite significant amount of economic growth. But if you were to repeat that exercise for an economy that already had a high capital labour ratio, and a more mature economy, if you like, that has already experienced significant economic growth and has built up a lot of capital per person over the years. If you were to provide such an economy with extra capital per person, you will get more per capita income, but not that much more. And this is a direct implication of diminishing marginal productivity of capital. Providing more capital per person is an effective strategy for promoting large-scale economic growth if you're dealing with an economy that doesn't already have a lot of capital. If you have an economy that already has a lot of capital, then providing even more capital is actually not going to yield much in the way of economic growth. The second implication relates to that second path to economic growth, the increase in total factor productivity. Suppose we did this for an economy that had a relatively low capital-labour ratio. Once again, you'll get some economic growth by improving total factor productivity, increasing the level of technology, for example, or the skill level of the labour force, perhaps improving the transport system. Any of those non-capital labour factors that influence growth, well, even if you have a low capital labour ratio, that's going to get you some more per capita income. But not as much of an increase relative to the economy that already has a high capital labour ratio. Here we get a higher increase in per capita income than in that first case. And these two implications are a very important lesson about the process of economic growth, namely that the road to economic growth, the path to economic growth, if you like, can be very different for economies at different stages of their development. An economy that is beginning economic growth, that is starting with a low amount of capital per person, then the most effective way of boosting per capita incomes is not through total factor productivity improvements, though that will help, it's through growing the capital stock. An economy that is more mature, that has had a longer history of economic growth, that has already built up its capital labour ratio, if it wishes to experience even more growth, then diminishing marginal productivity means that there's not much to be gained by further growth in the capital stock. Growth in that case is going to rely on growth in total factor productivity. What matters for growth is different across different economies.